Dear participants, very good afternoon. Welcome back to the FDP. And the afternoon session is about Raspberry Pi. And resource person is Mr. Vigneswaran. He is an embedded IoT developer, and he actually worked in various organizations. Like he worked in All Sense Technology Services LLP for a period of 3 years, from June 2018 to July 2020. Where his responsibilities for embedded product development and providing training in the field of embedded systems and Internet of Things. And he worked in Prista Tech Private Limited as an embedded IoT developer from November 2020 to 2021, and where he is used to develop a product, where his job description is full stack embedded product development from requirement analysis to production, testing and providing corporate training in embedded systems, IoT and Python. And at present he is working in Innovaskill Technologies Private Limited, and where he is responsible to design and implement hardware and software of embedded interface devices and systems from requirements to production and commercial deployment. And he developed drivers for different peripherals such as GPIO, I2C, and SPI, CAN, etc. And he has completed a full stack development from requirement analysis to production, conducted many workshops, and trained more than 1,000 students and faculty members. And he is having a software skills as in embedded Kale, Atmel Studio, Proteus, and PC board design and development, industrial automation, etc. And he is also having embedded domain skills like Atmega, AVR, and ARM controllers, Raspberry Pi, and worked in various types of Arduino boards also. And he is also having skills in wireless protocol and embedded communication protocols also. So, and since he is having hands-on training and working in industry, so it will be definitely a very good session. So I request the participants to interact with them and get clarify their practical difficulties and queries. I request Vigneswaran to take care of the session.
Yeah,
Sir, please.
Yeah. Wonderful. Thank you so much, sir. Yeah, really pleased with the introduction which you have actually given. Okay, for me. Yeah, first of all, I just sharing my screen. Okay, he have given abundant amount of information about me. Then what I have actually prepared here. So it's really great. Okay, fine. Just a quick start about here.
Just a few seconds, you can switch on your video and then you can go back to presentations just for snapshots.
Okay, for snapshots. Just a second, sir. Yeah, Vigneswaran Swami. Yes. Yeah, now you can actually see both myself as well as the screen as well. Okay, and really happy to be here. And AICTE is actually taking a lot of initiatives to introduce the newer technologies to the faculty members, students, and everyone. It was a great initiative. I have missed a lot when I was in the college days, but right now everyone is actually aware and just marching towards the latest technologies today. And we will actually discuss a lot about here, okay, at the end of the session. Okay, just an introduction about myself. Hello? Okay, I'm actually having 4+ years of experience. Someone is unmuted, I think. Can you able to hear me?
Yes, sir. Proceed, sir, please.
Yeah, okay. I'm actually having a 4+ years of experience in the embedded product development, and also having experience parallelly in training as well. Okay, for the college students in the field of IoT. And then before that also I have conducted a lot of sessions with the faculty members as well. Okay, the field of IoT, embedded systems and robotics, and also involved in guiding students in hackathons, competitions, and even some of the students will be really passionate about their final year projects. Sir, I have to do my own. Okay, even if it is small, I have to do myself. For such kind of students, I have really happy to guide them, and I have seen a lot of students like that. They are so much passionate about the things what they are actually doing, and I'm also the same. Okay, and doing a lot of research and development works on the latest technologies such as LoRaWAN, Sigfox, Thread, and Zigbee. Some of the terminologies is actually quite new to India, but some of the technologies is actually came, okay, in the way of smartphone. Okay, if you actually take a computer system or else a smartphone, it just have a complex embedded system, nothing but. Okay, right now if you take SSD, it's actually an embedded system. Before that, a mechanical hard disk, okay, to control an RPM optimization, they have used an embedded system. Okay, so but right now everyone is actually move on to the next level of technology, which is actually nothing but an industrial IoT. Likewise, a lot of stuff. Okay, with that, in this session, what we're actually going to see is how the Raspberry Pi is actually having the path to get through all those things. Okay, so that is what we are actually going to cover in these 2 hours. Okay, just listen carefully. Okay, only two requests. Okay, some faculty members actually know Raspberry Pi. Okay, but they are working in some independent projects or maybe some application area projects. Okay, on the time you may have some curiosity to ask questions based on the application which you are actually working. Okay, it is actually correct, nothing wrong about that, but the question time will be last 15 minutes. From 4 o'clock we will have the query session. Okay, on the time you can ask so many questions to me. I'm really happy to be here and answer all your questions. Whatever the things that you need, I can able to provide. Okay, fine guys. Okay, let's move into the workshop with all respect to the faculty members. Okay, okay, first of all, what is actually mean by an Raspberry Pi? Okay, so that is a major question. Okay, Raspberry Pi, Raspberry Pi, Raspberry Pi everywhere. Okay, first of all, what is actually mean by that? Okay, so that is a main important point over here. Raspberry Pi, which is actually nothing but a small single board computer. Okay, and it is having a lot of peripherals such as keyboard, mouse, display that we can able to connect with it, and it's just a single board computer. Okay, here you can actually see guys. Okay, it's a little beast. Okay, so it just looks like a credit card. Okay, everyone is actually marketing like that, but really not at all. But anyhow, okay, we can actually take like that. It was very very small, and even though if you need to attend some of the meetings or else some general purpose works like sending emails or some of the general purpose uses, you can actually use a Raspberry Pi instead of a computer. Okay, I won't actually take a too much hype to the Raspberry Pi, but it is having a immense capabilities. Okay, to perform very much better. Okay, today, because a lot of GBs of RAM is actually there in Raspberry Pi. Okay, before it is quite slower, just comes with 512 MB of RAM. Okay, even with 256 MB, I think. Not clear. Okay, we will actually see in slides as well. But 1 GB, 2 GB. Right now, a lot of variants up to 8 GB of RAM is actually available, and also you can use SD card as an hard disk here. Okay, we will have a hard disk in the system, right? Likewise, SD card will act like that. Okay, here it just actually used for the real-time image and video processing. Okay, in lot of projects in Greater Chennai Corporation, they have actually conducted some test and used for real-time applications using Raspberry Pi. Okay, and it is quite slower than laptop and desktop, and its performance quite equal to the Pentium processors. Okay, they're actually seen, right, which has been later released in 2003, 4, on that period. We will see a lot of Pentium series. So it just equal. Okay, it just equal the performance with that. Okay, and then they actually provide their own OS. Okay, which is nothing but Debian Buster OS right now. Before that, it is an Debian Stretch and Debian Jesse OS is actually released previously. Okay, before these two OS. Okay, and they also provide a light-weighted Noobs OS. Okay, everything is actually based on Linux. Okay, all the OS they have written, okay, based on the Linux operating system and Debian. Okay, they are developing it. Okay, and we also can install some of the third-party vendors such as Ubuntu. They are actually providing one OS, and likewise a lot of companies, okay, like Kali Linux, they are also providing their own OS to the Raspberry Pi, BeagleBone. For such kind of boards, they are also using. Okay, and Raspberry and OS is official operating system. Okay, for the Raspberry Pi. If you want to use Raspberry Pi with the recommended OS, okay, if you ask the question, right, Vignesh, what is the OS we can install in Raspberry Pi means, I always suggest go with the original OS, Raspbian OS. Okay, and for the storage purpose, I always recommend to have an 8 GB of recommended SD card. Okay, 8 GB size of the SD card is actually needed to store all the details with the OS files as well. Okay, that's great, guys. Okay, just an introduction. We will see much more and more deeper right now. Okay. Yes, the Raspberry Pi have just came a long way. Okay, here you can actually see the family Raspberry Pi. Okay, model A, B, A plus, B plus, all those things have been released. Okay, I have actually told, right, the memory is 256 MB, and then here you can actually see 512 MB as well. Okay, initially it has been released in two variants of RAM. One is the 256 and another one is 512 MB. Okay, just make note of it. Okay, at some point of time it will be really useful. Okay, and then it just comes up with 26 pin. Okay, I won't actually commit 26 GPU pins. Okay, nothing like that. The total number of pins which has been punched out from the BCM2835 is actually the number 26. There are actually 26 pins, and the initial release have came in 2012 and 2013. Okay, and then here you can actually see, guys. Okay, the A models, okay, they won't actually come up with good memory of RAM, as well as they won't actually have Ethernet port. Okay, so it's always advisable, do not buy the A or A plus models. Okay, always go with the model B. It is actually the very good one. Okay, and also when it is comes to Raspberry Pi 2, which has been later released in 2014-15 and during the duration of time, and then here you can actually see it's actually having the memory of 1 GB. Okay, and form factor is actually standard. Okay, standard size of Raspberry Pi. That is what the main thing that they are actually representing here, and it just comes up with the Ethernet port. Okay, the A plus, the A models, okay, never comes with the Ethernet port. The B models always comes with the Ethernet port. Okay, and Unfortunately, it doesn't have any wireless communication. Okay, what you have to do is we have to put the dongle, okay, to enable the Wi-Fi. Okay, and then here you can see, guys. Okay, Raspberry Pi Zero. Okay, it is actually one of the avatar of the Raspberry Pi series. Okay, but it is also not at all a successful series. Okay, according to me. Okay, no offense with the Raspberry Pi series. Okay, the 512 MB of memory. Okay, and it is quite ultra compact. Okay, it won't actually come up with Ethernet, but it have a lot of wireless with even a single band Wi-Fi. Okay, just released in the year 2017, I think, late in the 2017. Yes, it is. Yeah. Okay, guys, and Raspberry Pi 3 and 4. Okay, there is not at all a big difference. Okay, from the Raspberry Pi 3, they have completely stopped the A series because it is quite failure model. Okay, because with some pennies, if you put extra, you can actually get the B model. Okay, it is a really good model when it is comes to the Raspberry Pi. Okay, if you need an Raspberry Pi right now, okay, always the best option is go with the Raspberry Pi 4 or 2 GB or 4 GB variant. Okay, that would be really good. Okay, and also among these, okay, if you ask the question like Vignesh, what is the best model according to you, means I will actually select the Raspberry Pi 3. Okay, because this series is very much famous. Okay, it doesn't run that much. Okay, but B and B plus model, they have captured a whole area of market, even in the industries as well. Okay, from here on, they have started to capture the industries. Raspberry Pi 3. Okay, because initially Raspberry Pi is actually released for the purpose of teaching children about some technologies. Okay, I will show you in the UI of the Raspberry Pi. Okay, so don't worry. And then here you can actually see this Raspberry Pi 4. Okay, just comes up with the processor DCM27111. Okay, which is nothing but an ARM processor. Okay, with the variants of 1 GB, 2 GB, 4 GB, and 8 GB as well. Okay, and also they have released one computer as well. Okay, based on the Raspberry Pi 4. Okay, and finally, there also comes in the place of microcontrollers. Okay, they have released their first microcontroller RP2040 based on Cortex M0. Okay, with a memory of 264 KB. Okay, and here also no Ethernet wireless option is actually not there. Okay, you have to either use some of the shields. Okay, some of the famous shields such as Espressif ESP32 or ESP8266, they have to go for the wireless option. Okay, and it has been released in the earlier part of 2021. Okay, this year. Okay, guys, fine. We have seen a lot of things right now. Okay, so the Raspberry Pi, which has been initially launched in the year 2012, in 2021, they just came in now. Okay, so you may have one question. Okay, why the Raspberry Pi 3 is best than the Raspberry Pi 4? Why? Because here the heat optimization and the performance to size ratio is really good. Okay, but when it is comes to Raspberry Pi 4, okay, initially I have told, right, okay, they are keep on marketing like credit card size computer. Okay, to save the standard form factor, what they have done is with the same size, okay, with a lot of risk taken, they have keep the processor. Okay, they have provided the heat sink, okay, a steel heat sink, okay, but it doesn't work really. Okay, you need to provide a lot of cooling to the Raspberry Pi 4 while it is running. Okay, whenever it just you are in the meeting or else you are sharing some video contents or else you are actually watching some videos, means it will consume a lot amount of power. Okay, and So that's why I'm just not backing this one. Okay, but right now there is no option. Okay, this one everyone is accepted by the universe, so you can actually go with the Raspberry Pi 4. Okay, if you need to choose the latest thing. Okay, that's great, guys. Now we can move on to the next slide. Okay, here you can actually see this is the Raspberry Pi 3. Okay, just a second. Just stop the video. Fine. Here you can see this is the Raspberry Pi 3. Okay, so this is how the things will be looks like. Okay, we are going to explore a lot of hardware. Okay, here you can see, guys, it is having the quad core processor. Okay, a 4-core, 4-thread processor. Okay, it just runs on 1.4 gigahertz. Okay, the chipset is BCM2837, and it is actually an 64-bit CPU. Okay, like our general purpose computer, which we are actually using in our day-to-day life, right? Okay, likewise, it is also comes up with 64-bit CPU. Okay, and then here you can see, okay, like our system, it just have the USB ports, and then here you can actually see an Ethernet port, okay, with the same specification how our the computer motherboard is actually having. And also here you can see, guys, here one micro USB port, okay, in the Raspberry Pi 3, okay, and one HDMI port, and one CSI camera port, okay, dedicated Pi camera, okay, and also here you can see an audio jack, okay, and SD card slot, okay, which is actually present beneath the display port. Okay, this is actually the display port. Okay, just see the cursor position carefully. Okay, this is the display port. Beneath the display port, yeah, SD card slot will be actually be there. And also with no surprise, okay, from Raspberry Pi 3, they have actually started to capture the market of the industry. Okay, industrial Internet of Things. Okay, they have already started to capture when this little beast is released. Okay, and it just having an Bluetooth and Wi-Fi. Okay, which is quite on board. And also here you can see, guys, there are actually 40 GPU pins is actually there. Okay, here in this image they have given 40 pins general purpose input output, but it is not actually like that. 40 pins is actually there. Okay, 40 pins is actually there. Among that, around 26 to 30 pins only the general purpose input output pins. Okay, a genuine general purpose input output pins. Okay, we just have everything whatever the computer have. Okay, any doubts? Any doubts? Okay, fine. Okay, just move on to the Raspberry Pi 4. Okay, here you can actually see, guys. Okay, so here also the same. Okay, we have the USB ports and a stereo audio port. Okay, which is a 3.5 mm jack. Okay, like the Raspberry Pi 3. And here you can actually see this is an camera port. Okay, like the same. Okay, which you have seen in the Raspberry Pi 3. Okay, it's very similar. Okay, no need to worry about that. And then here you can actually see two HDMI ports is actually there. Okay, two micro HDMI ports is actually there. Okay, just a second. Okay, thank you. Okay. I actually checked for doubts in the chat section. Okay, and then here you can actually see, guys, two micro HDMI ports, and here you can see the USB-C power supply. Okay, which is the recommended supply is 5 volt 3 amps. Okay, when it is comes to Raspberry Pi 3, okay, when it comes to Raspberry Pi 3, a micro USB port, the recommended power supply is 5 volt 2 amps. Okay, 5 volt 2 amps. But in Raspberry Pi 4, the USB power recommended you have to provide to the Raspberry Pi is 5 volt 3 amps. Okay, it is what the thing that you have to keep in mind. And then here you can see this is the 2.45 gigahertz wireless with Bluetooth low energy 5.0 version. Okay, they have actually given, and gigabit Ethernet like the same what we have actually seen. Okay, and then this is the processor. Okay, which is nothing but BCM 2711. Okay, it is also an 4-core 4-thread processor. Okay, and the performance is really great. Okay, when it is compared to the Raspberry Pi 3. Okay, the only main concern is the heating issue of this chip. Okay, it is a major concern. Otherwise, there is no problem in using this. If you can able to provide cooling with the amount of price that you can able to spend, means you can go ahead with this particular model. Otherwise, you can buy Raspberry Pi 3 B plus model. Okay, that's great. Now, everyone will actually have the question. Okay, most of the times, okay, if I'm actually taking a session all the time, I'm just seeing this same question. Okay, it's almost 2 to 3 years. Okay, I'm working in the training field. Okay, in a full-fledged manner. Okay, initially because I'm also a trainee, right? After that, one day I have become anything else. Okay, right now in this position, but on that particular time to this time, okay, most of the people is actually asking is what is the actual difference between an Raspberry Pi and Arduino? What is the difference? Okay, let's see. First of all, Raspberry Pi is actually a single board computer. Very simple. Okay, it just do all the stuff. Okay, whatever the things the computer can do. Okay, it will just do all the stuffs. Okay, but Arduino is not actually like that. It is a microcontroller. Okay, so some of the electronics faculties will be there. Okay, so they actually know very well about a microcontroller. Okay, it is just a single chip computer which is actually having all the peripherals inside it. Okay, maybe like it is like a single chip, a limited computer. Likewise, we can actually say, okay, with the limited amount of functions, it can just do with its strength. Okay, nothing more than that, nothing less than that. Okay, so that's all about the Arduino board. Okay, it's actually comes up with Broadcom. Okay, this is the manufacturer of system on chip. Okay, it just comes up with the ARM Cortex A series microprocessor, and then it is based on when it is comes to Arduino. Okay, Atmel is the manufacturer. Okay, and it just uses Atmega 328P microcontroller. Okay, and then here you can actually see Debian OS. Okay, it just work on a Linux OS. Okay, but the microcontroller doesn't need an operating system. Okay, but when it is comes to Raspberry Pi, it can able to perform multiple tasks. Okay, I actually told it is a general purpose computer. Okay, and but the Arduino is usually it just perform a single task. Okay, but with some programming methods we can do some 2 to 3 tasks at a time. Okay, parallelly. Okay, but when it comes to Raspberry Pi, there is no problem at all to run hundreds of tasks in parallel. Okay, and then here you can see, guys, all the necessary components like processor, RAM, storage, connectors, GPU pins. Okay, everything is present in the Raspberry Pi board. Okay, but a microcontroller, okay, you have to give one board. Okay, a bring up board, which is nothing but Arduino board. Okay, everyone is actually like telling like Arduino is a microcontroller. Likewise, okay, Arduino is just like a brand. Okay, they are creating the boards. Okay, based on the Atmel microcontrollers. Okay, the chipset is Atmega 3280. Okay, that is the only thing that you have to understand. Okay, the chip producer is Atmel. Okay, Arduino is just a brand. Okay, they're just giving an open source solution to everyone. Okay, and also some of the advantages is actually there, and also disadvantages is actually there. Okay, we will discuss in the last few minutes. Okay, and here you can see both the hardware and firmware of Raspberry Pi are closed to source. Okay, it is quite licensed and we can't able to access it. Okay, both hardware and firmware, but Arduino is developed and given by everyone. Okay, tomorrow if you actually become genius in Arduino means you can create your own board and release it in the market. Okay, no one cares, but one thing is you have to just communicate with Arduino. Okay, with the ideas that you have and what kind of market capture. Okay, how much you know about the Arduino market. That is very much important. Okay, more than the product that you are providing to a company. Okay, they always thinks about in the way of profit. Okay, so we have to think about that. But if you are capable in doing Arduino boards means you can also negotiate with them. Okay, and then here you can see the Raspberry Pi SBC. It just have 40 pin on the board itself. Okay, we can actually connect LEDs, sensors, push buttons. Okay, we will also do some experiments. Okay, just to give some virtual hands-on experience. Okay, I will be programming. Okay, here, but that is what. Okay, and then here you can see, guys, Raspberry Pi SPC. Okay, at this point we have completed, I think. Okay, yes, the Arduino board. It is also comes up with the digital input output pins and some of the ADC pins as well. Okay, it just comes up with everything. Okay, and then here you can see the Raspberry Pi is just essentially used as an computer. Okay, likewise, almost 2 to 3 points. It just mentioning like Raspberry Pi is like a general purpose computer. Arduino is just an microcontroller board. You can just plug and play. Okay, but for Raspberry Pi, you have some procedure to, first of all, you have to put the OS with the SD card, and then you have to insert the SD card. And then finally, there are some booting procedures is actually there. Everything I will show. Okay, so don't worry. It won't be too much theoretical. Okay, from certain point of time. Okay, and some other questions will be actually like that. What are the difference between Raspberry Pi and computer? Okay, is Raspberry Pi is having the capability to overtake computer? Let's see. Okay, first of all, construction is quite simple, and also within the motherboard they have accommodate everything. Okay, RAM, buffer memories, and gigabit Ethernet, and all the controllers they have given there itself. It was a Herculean task, and really hats off. Okay, but when it is comes to computer, okay, based on the performance, based on the cooling, okay, there are a lot of factors we need to consider, but still it is the original beast. Okay, when it is compared to the Raspberry Pi, and also the size you can actually see, and also when it is comes to the price, you can actually see the computer is around 3,500. Okay, one tip for you guys. Okay, most of you guys may be parents. Okay, if you need to just make the students, okay, make your children to attend the online classes, okay, the Raspberry Pi will be a very good idea, honestly. Okay, it will be work very well for that. Okay, because in my home my sister have tried. Okay, just worked out. Okay, fine. And then here the connectivity is just 4 USB ports, one HDMI monitor, and one audio port. Okay, not only one HDMI. Okay, they have given the point based on the Raspberry Pi 3, but in Raspberry Pi 4, how many HDMI ports? Two micro HDMI ports. Okay, and also one audio port. Okay, it's quite similar. Ethernet port, Bluetooth, Wi-Fi, everything is actually present. Okay, and the computer is actually be like it just highly depends on how much investment you just provide them. Okay, such kind of connectivity you will actually get, okay, without any regret. Okay, and then when it comes to architecture, it's just based on advanced risk machine, but when it comes to computer, it's just based on AMD 64, AMD 32. Okay, and when it comes with the screen, means just won't actually comes up with screen, we have to buy. Okay, for computer it is actually possible, can have a screen. Okay, just for an example, if you take laptop, it is also a computer. Okay, it can have a screen. Okay, it is what they are actually mentioning. Okay, that's fine. And then here you can actually see this is the Raspberry Pi. Okay, just go with the quick hello, can you able to hear me?
Yes, sir.
Okay. Now just take a look over here. Okay, we can just go with a quick recap. Okay, here you can see this is the Ethernet port. Okay, these are all the USB ports. Okay, this one is the processor. Okay, only the main thing I am just referencing here. Okay, nothing more than that. Ethernet port, USB ports, BCM 27111 or BCM 2537 or 36 likewise. Okay, and then here you can actually see this one is a Type C port. Okay, for the Raspberry Pi 4, but in the Raspberry Pi 3, it's totally different, which is just comes up with micro USB. Okay, and then here you can actually see these are all the two HDMI ports. Okay, micro HDMI ports in Raspberry Pi 4. In Raspberry Pi 3, only one HDMI port. Okay, like our TV, our system have. Okay, even though if it is a graphics card, it also have one HDMI port. Okay, Raspberry Pi 3 old model HDMI port will be there, but in Raspberry Pi 4, two HDMI ports. And here you can see the 3.5mm jack, and this one is the camera port, this one is the display port. Beneath this port, okay, we have a SD card slot. Okay, so that is the thing you have to understand. Okay, and some of the required software, okay, you have to install. Okay, so one of the thing I need to install right now. Okay, I will just give you the SD card formatter. Okay, just search for SD card formatter. Okay, just go over here. That's great. Okay, and then here you can actually see. Okay, there are actually a lot of versions is actually they have given. Okay, for Windows. Okay, just accept this. Fine. Just save this one. Okay, just show in folder. What I'm actually going to do is just come over here, just paste it here. What I'm actually going to do is just come over, extract to G. That's good. Just come inside and click setup. It will ask for everything and it will install. Just accept the license agreement. Okay, because this is a software I didn't actually install. Okay, that's fine. Great. We have installed the SD card formatter, guys, successfully. Okay, here what you have to do is just insert your card. Okay, it will be denoted over here. Okay, so just watch the cursor portion. Okay, you have to carefully need to watch this. Okay, and then the formatting options. Okay, you can go with quick format or else override format. Okay, no problem at all. Okay, just to go with the quick format. Okay, if the SD card is quite cheap and it just comes up with a lot of classes. Okay, it's actually, oh sorry, it's actually better to go with just go with Samsung Evo Press. Okay, this is a really a good SD card. Honestly speaking, the performance is really good. Okay, if you actually put it over here means the life will be really good and also the speed as well. Okay, and don't hesitate and just go and buy this. And the recommended storage is 8 GB. Okay, if you want to go extra means you can buy 32 GB or 64 GB, whatever else. Okay, just don't go beyond 64. Okay, that is also a problem. And don't go lesser than the 8 GB. Okay, so don't go for 4 GB and all. Okay, it won't really worth it. Okay, that's great, guys. Okay, just open the SD card formatter. Okay, if you insert the card, it will actually show the card profile. Okay, just click that and select either one of the quick format or overwrite format. Okay, overwrite format may damage SD card at a certain extent. Okay, if you go means there is advantage as well, also disadvantage. The advantage actually is it will erase all the core files of the SD card as well. Okay, overwrite format. Okay, except only one file to accept the storage. Okay, otherwise it will you won't actually recover. Okay, that's the major problem with the overwrite format. Okay, if you are actually going to use your SD card dedicatedly for the Raspberry Pi means, it's actually better to go for overwrite format because uh, these files of the SD card, okay, the core files of the SD card won't mingle with the boot files, okay, which we installed in this SD card. Okay, so that is what I am actually trying to tell. And then here you can see this one is the quick format. Okay, the quick format is always the safest option. Okay, just try this first. Okay, if not, go with overwrite format. Okay, just a second. Fine. That's great, guys. Okay. Now what we can actually do is, okay, so it is one of the SD card. Just a second. Yeah, it is one of the SD card software. Okay, which helps to format the SD card. Okay, here I can actually choose a quick or overwrite. Okay, like the same. Okay, and choose the drive and size and just click format. Okay, it is actually Panasonic SD card format, I think. Okay, this software. Okay, then the step 2 is Win32 disk imager. Okay, Win32 disk imager is actually be there. Okay, it is the actual software. I will actually show you. To disk imager. Okay, just goes with oh my god. Okay, this also we need to install. Okay, I will actually show this. Just go over here and then just download this. That's great. Okay, so Win32 disk imager. Okay, the first step is actually you need to format the SD card. Okay, using the SD card reader. Okay, and then you have to install Win32 disk imager. Okay, just create an just finish this. Okay, and then here you can actually see this is the image file. Okay, where you have to select. Okay, in this case I'm actually having an OS. Okay, I will actually show you. Okay, Raspberry Pi, that's great. Raspbian Buster. Okay, so this is the image file. Okay, disk image file. Okay, the name is. Okay, I'm just going to open this one. Okay. And then what I will actually do is, okay, I will just select the device, okay, which is nothing but E or AF drive. Okay. So just click that, and then no need to worry, just give right. Okay. The rest things it will actually take care. Okay. Very simple, guys. Okay. Just insert the SD card to the SD card reader and just plug it in your system and just open this SD card formatter. Okay, and then what you have to do is we have to just format the SD card, and then we have to open the Win32 disk imager and select the image file and write once. Okay, that's it. Okay, nothing more than that. Okay, and then the fourth step is they have actually given the same. Okay, on the previous time the Raspbian Jessie is actually there. Okay, we are selecting, and then in the fifth step I'm just giving the right to it, and then it's just successfully written. Okay, and afterwards what you have to do is, okay, just open the SD card, okay, in the boot E section. Okay, it will be named as boot. Okay, and E or F or G. Okay, maybe depends upon your computer partition. Okay, so based on that, here you have to just create an SSH file. Okay, an empty SSH file. Very simple. Okay, that's great, guys. Okay, so these are all the quite simple steps. Okay, initially if you are just seeing this procedure for the very first time, okay, really it will be quite confusing. Okay, but once if you are used to it, you can be able to do a lot of experiments with it. Okay, that's great. Okay, everything will actually comes up with practice. Okay, so that is an important point. Okay, okay, very easy steps, and also I will have no hesitation to share this file. Okay, I will share this resource. Okay, so no problem. Okay, and then here you can actually see, guys. Okay, from here on we will actually go over here. Okay, so with internet only, everything is actually working right now. Okay, which is nothing but a global wide area network. Okay, which can connect computer systems across the world over the TCP or UDP. Okay, works with the internet protocol suite. Okay, we all know it just comes up with the TCP layers or else UDP layers. Okay, TCP, which is nothing but a transmission control protocol. UDP, user data control protocol. Okay, if you are actually going for any streaming applications, okay, it just comes up with the UDP. Okay, user data protocol. Okay, we are actually seeing a lot of just a second. Okay, if we are actually comes up with the request response, okay, for that the TCP is very important for any streaming applications like the Netflix, Hotstar. Okay, more or less they are actually using the UDP. Okay, for the link verification only they will be using the TCP because it won't actually care about what data they are sending. Okay, just keep on sending the data based on the programmer. But for TCP, it always verify whether the end device is actually received the actual data or not. Okay, so based on that only, there are a lot of error codes which we will see in the HTTP as well. Okay, fine, guys. And then Raspberry Pi, okay, is actually mainly using in those days based on the Internet of Things only. Okay, the Internet of Things is not actually a wild word. Okay, maybe it looks like, but it is quite very simple, guys. Okay, Internet of Things is a group of things which is such as at your home. You will have a lot of devices such as fan, light, air conditioner. Okay, if it is having the capability to communicate with each other from one thing to another through internet with or without human interaction. Okay, That is actually called as an Internet of Things. Okay, and there are a lot of examples. Okay, even in the definition itself, you can see fan is actually there, air conditioner, and then here you can see a washing machine is actually there, right? Okay, so these are all actually the embedded systems. Okay, so the embedded systems only actually providing the base structure for the Internet of Things. Okay, and even if you take fan nowadays, it also becomes an embedded systems. Okay, not like an single phase induction motor in the previous days. Okay, right now it just comes up with one technology called like I forgot it, but uh, the technology is actually really good. Okay, okay, once I get the thought of it, I will actually convey all those things. Okay, BLDC, yes, BLDC, brushless DC motor. Okay, because a microcontroller unit is actually need to be there to control that particular motor. Okay, so hence it just becomes an embedded systems from a general purpose single phase induction motor. Okay, and here you can see, guys, we actually discussed who actually providing the base for the Internet of Things embedded systems. Okay, and some of the lively examples. Okay, in general day-to-day use. Okay, in some of the homes we can actually see like Google Home, Amazon Echo, and then be like some of the even fans which is having the compatibility with the Google Home and Amazon Echo as well. Okay, and these are all the common IoT technologies. Okay, here you can see who are all actually there. Arduino, Intel based boards, Galileo boards is actually there based on embedded. Raspberry Pi is actually there in the list. Beagle board and Kiwi board. Okay, so a lot of manufacturers, they're actually providing a lot of solutions in the IoT world. Okay, IoT, which is actually, yeah, one step higher than the embedded systems. Okay, embedded systems don't have an internet connectivity, but IoT devices will have. Okay, so only I have just mentioned here who actually provide the base for the Internet of Things, embedded systems. Okay, that's great, guys. Okay, I will give this whole slide for reference. Okay, I will actually share with Ravi sir as well. Okay, so just move on with the experiments and just come up with some exciting results. Okay, that's great. Okay, if there is any doubts. Okay, Sanjay Prasad actually asked which image file to select. Okay, it's actually based on the image file which you download. Okay, I will actually show the download procedure. Okay, you can actually see, just a second. Just go over here, sir. Okay, Raspberry Pi OS. Okay, just go over here, and then here you can actually see raspberrypi.com, right? Okay, here you have to select software. Okay, already we have selected. Okay, because the link is come up with that way. Okay, and then here you can see download for Windows is actually there. Just click it and install. Okay, so it is actually an image file. Okay, a disk image file. Okay, I have actually showed here. Okay, this one, Raspbian Buster. Okay, this is the OS I have actually used. Okay, before that a lot of versions have came, not only Buster, Stretch OS is actually there, not only Stretch, Jesse OS is there. So many versions is there. Okay, in this case I'm actually selecting the Raspberry Pi Buster OS. Very simple. Okay, hopefully your doubt is actually solved, I think. Okay, can you able to understand Sanjay Prasad, sir?
Yes, sir. Very much clear, sir. Thank you.
Okay, thank you so much. Fine, we can just go into the experiments. Okay, before that, two more softwares you need to install. One is Putty. Okay, Putty is a software. Okay, just go over here and click here and just install the 64-bit version. Okay, just do this. Okay, very simple procedure like any other software which we are using in day-to-day life. Okay, and next software is very interesting software, VNC server. Okay, because I'm actually going to connect to the system through an Ethernet cable, and I'm just going to use. Okay, for that it will be really good. Okay, if you have a display, you can boot up. Okay, once the SSH file is actually created there for the Raspberry Buster. Okay, so just click over here and download VNC server 6.8.0. Okay, just click and download here. Okay, I have everything okay with me. So what I'm actually going to do is, okay, the kind of time that we have to go a little bit fast, but not too much fast. Okay, so here I have an SSH IP, okay, like 169.4254.0.10. Okay, so I'm just going to open this. Okay, here you can actually see, guys, it just asks for login. Okay, the username is default by, and then password is raspberry. Just a second. Okay, here what I'm actually going to do is I'm just going to run the VNC server to work remotely with the Raspberry Pi using an Ethernet cable. Okay, so 192.168.1.102:1. Okay, fine. And here is the VNC viewer. Okay, it's actually be there. Okay, what we have to do is, okay, I have already selected because I have used for multiple times. Okay, with this PC. Okay, so it is actually be there. Okay, otherwise you have to enter the address here. Okay, so I'm just going to enter here. Password is raspberry. Just give OK, and then it's fine, I think. Just a second. You can actually go ahead. And here you can actually see some warning will actually come. Okay, SSH is actually enabled because I'm just connecting through an shellnet, and also Ethernet cable is used, right? So I have to go for this. Okay, so just give OK, give next. Okay, no need to configure as this time. Okay, fine. Okay, this is how it actually looks like once you put OS. Okay, this is the actual interface of the Raspberry Pi Buster OS. Okay, which has been produced by Debian. Okay, they are actually one of the leading Linux distributors. Okay, and here first step you have to do with the Raspberry Pi is go to terminal. Okay, sudo apt get update. Okay, so it is a first command you have to provide. It is a Linux command. Okay, so what it will actually do is if there is some of the important packages need to be updated, means it will just update everything for us. Okay, another one is actually there, sudo apt get upgrade. Okay, if there is some software upgrades, okay, with the softwares like here you can see, okay, these are all softwares like, okay, if there is any upgrade is actually available, means this command will actually provide sudo apt get update. Okay, but in this case sudo apt get update. Okay, That's great. That's fine, guys. Now, what we're actually going to do is, just a minute. Okay. We have just come out of this. One second, one second. I will join through phone as well. Okay, fine. Right now we can do some of the experiments. Okay, for that purpose, just listen carefully over here. Okay, can you able to see my screen? Anyone?
Yes, sir.
Yeah, okay, fine. Just go over here. Okay, here in the programming section, just go to the Tony Python IDE. Okay, because it is quite easy to use interface. Okay, because some of the faculty members maybe they are not in the zone of Linux based environments. Okay, otherwise we can use the terminal itself. Okay, so we are just going to do the Python programming. For that, Tony Python IDE is really good. Okay, here just see over here. Okay, here this is the Raspberry Pi. Okay, and then here you can actually see this is the LED. Okay, which we have actually connected. Okay, and one resistor have been used. Okay, and you can connect with any digital pin. Okay, you have to represent the correct digital pin. Okay, in my practical case, okay, the pin number I have actually used is 14. Okay, at this case maybe a different number. Okay, here also 14 I think, but in my actual scenario, okay, I'm actually going to use the pin number 14. Based on that, I'm just going to show the output as well. Okay, let's do some programming stuff. Okay, first command you have to provide is import rpi dot gpio as gpio. Okay, and next thing is input time. Okay, and two libraries we have actually imported successfully. One is the GPIO library of the Raspberry Pi. Okay, I am just giving an alias name as GPIO. So I don't actually need to use this one for so many times. Okay, I can use GPIO. Okay, instead of everything. Okay, so that is what the actual thing over here. Okay, and then here you can actually see, guys. Okay, GPIO dot set mode. Okay, set mode means it just perform the GPU numbering systems, okay, based on the Broadcom numberings or else the pin numberings. Okay, Broadcom numberings means it was quite simple and straightforward. Okay, in this case, what we're actually going to use is GPIO.BCM. Okay, and GPIO.set warnings. It is the next command we are actually going to use. Okay, here we are just going to provide false over here. Okay, we have actually imported two libraries. Okay, and then here you can actually see GPIO.setMode. Okay, here GPIO.BCM is actually here. Okay, and then here you can see, guys, I have set the warnings to false to avoid some of the power warnings, because I'm not using an recommended supply. Okay, for the shorter duration of time only I'm actually using, so no problem at all. Okay, for the longer duration, you have to always, you need to use the recommended power supply. Okay, to avoid all the GPU power warnings, what I'm actually setting is the false. Okay, so I won't capture with any of the errors. Okay, in near future. Okay, for the purpose of GPU.set mode means we just use the Broadcom chip numberings. Okay, in the chip itself, we have pin number 1, 2, 3, likewise, right? Okay, it will actually use the chip numberings. Okay, in this case, I'm actually going to use the pin GPIO.setup. Okay. Here the number is 14. Here what I'm actually going to do is GPIO.out. Okay, I will just comment it out. Okay, importing the Raspberry Pi library. Okay, Python library is actually constructed. It's just importing the time. Okay, and then here setting the mode as Broadcom and numberings. Broadcom. Broadcom numberings. Okay, chip numberings. Okay, we can actually start. Fine. And then here always set the warnings to false. Okay, to avoid some power issues. With the GPIO. Okay, and also just setting up pin as out. Which pin number? 14th pin. Okay, can you able to understand? Everyone?
Yes, sir.
Yes, sir.
Thank you so much. Right now, I'm just going to create a while loop. Okay, while of 1. Okay, I'm just providing an indentation here. Okay, just very much important in Python. Okay, I have a little bit worry. Okay, some people may not know Python. Okay, for them it is quite they have some trouble over here. But anyhow, it will just give you some idea what the things is actually happening here. Okay, just see that alone. Okay, so if we have a chance to have an extended session on the time, we will see Python as okay from the very basics. Okay, so as of now, what we can actually do is we can just go ahead. Okay, right now file of 1. Okay, so here what I'm actually going to do is GPIO. J Ramakrishnan, you are actually sketching, I think. Hello. Where is this? Okay, fine. Thank you so much. GPIO dot output. Here I'm just going to provide 14,1. Okay, 1 which is nothing but y. Okay, making the 14th pin high. Pin as high. Okay, very simple. Okay, and I have actually used time library here, right? Okay. Time.sleep. Just providing over here. Just provide 0.5 seconds. Okay. As of now. And also what I'm actually going to do, very simple. Okay. 14th pin as low. Okay. Interrupting the processor for 0.5 seconds. Okay, just nothing but 500 milliseconds. Okay, and then making the 14th pin as low. Very simple. And again, time.sleep. Okay, I'm actually interrupting the processor for 0.5 seconds for high, also for the low. Okay, otherwise we can't able to see the blinking in a full-fledged. Okay, with our NAC. Okay, so just run the script. Okay, blinking, a lot of blinking tests is actually there. Okay, because this pi is used for a lot of training sessions. That is the actual problem. Okay, let's see what are the errors is actually coming here. Okay, at my case, it is actually blinking. Okay, I will start the video. Okay, just see the segment of Vigneswaran Saminathan. Okay, so I'm starting the video here. Just a second. Can you able to see the LED is actually blinking? Okay.
No, sir.
No, sir.
So at the Vigneswaran Saminathan. Okay, the name is actually Vigneswaran Saminathan. There I am actually sharing the video. Okay, with my I have connected with desktop, so I didn't have the video section. Okay, here. Can you able to see?
Yes, sir.
Okay. Okay. Thanks so much. Thank you so much. Okay. That's great. Okay. Right now, what we're actually going to do is, I'm just going to stop the video right now. Okay. So, okay, the session is understandable, right? Okay, at least at some point of view. Anyone?
Yes, sir.
Okay. Thanks so much. Okay. Now we can actually going to interface push button right now. Okay. So in this case, you can actually see over here. Okay. First of all, we will go over here. Okay. Raspberry Pi with the push button. Okay. There are actually two types of inputs. Okay. We can have. Okay. Whether it is internal or external. Okay. In this case, we can discuss about some input pull. Okay. Here, the GPIO input. Okay. You are just connecting one part of the button board here. Okay. Just to pull up to the VCC. Okay. In a Raspberry Pi, most of the pins is actually 3.3 volts. Okay. So here I'm actually writing, okay, not 5 volts. It's actually 3.3 volts. Okay. All the GPIO pins will actually support this logic only, not the 5-volt logic. Okay. Just for an instance, okay, I have got the image from the outside. So it's denotes 5 volts. Okay. Not at all 5 volts in the Raspberry Pi case. It just stands 3.3 volts. Okay. And then we are just giving an input over here. Okay, this is the button. Okay, one button is actually connected with the pull-up high and also the reading of the microcontroller as an input, and also the another part of the button is actually connected here. Okay, and then here the input pull-up low, it is actually pull low, okay, or else pull down. Okay, here you can see the same GPIO pin microcontroller input will actually come over here. Here you can see the resistor will actually pull down to ground. Here it is pulled up to the source. Okay, 3.3 volt, but here it just pulled down to the ground. Okay, here 3.3 volt. And in this case, one more important thing you have to understand is, okay, in my practical case, okay, what I have used is I have used an internal resistor. Okay, I don't need an external resistor comes into play. Okay, because even the microprocessor or microcontroller is actually come up with the internal pull up or pull down resistors. Okay, so no need to worry about that. So I'm just canceling this resistor. I'm just using this internal resistor over here. Okay, it also the same. Okay, between 3.3 volt to GPIO pin. Okay, but it is internally connected. So what I can do, one part of the GPIO pin I can connect to the one end of the push button, another end of the push button I can connect to the ground. Okay, here the actual pin number I have used is 21. Okay, let's see how it goes. Okay, okay, thank you so much. Now, what we are actually going to do is, we are going to do another program over here. Okay. Here, just remember the 21st pin. And also we will do one more experiment. Okay. By combining both the blinking program as well as the push button program. Okay. That's great. Right now, guys, here what I can actually do is very simple. RPA library, GPIO as GP, and then input time. Okay, and then in this case, what I'm actually going to do is GP. Okay, here actually I have used GP, right? So hereafter I can use GP here. Okay, no problem for me. Okay, GP dot set mode. GP dot BCM. Okay, and then GP dot set warnings. False, and then GP dot setup here. Okay, listen carefully. Okay, here we are actually going to enable the pull up. Okay, so here there are actually 3 arguments comes into the play. Okay, first one is the pin number 21. Remember, second one is GPIO dot in, and then finally pull up down. Okay, and here you can actually see. So first one is the pin number, second one is the mode of the pin. Okay, in which mode it's actually going to work. Okay, in this case it is output, so out GPIO dot out, but here GPIO dot in, but here in this case what you have to do, GP. Okay, why? Because in this program I have given alias name as GPIO, but not here. I have given as GP, so only GP dot in. Okay, so it is quite confusing, means we can change like this. Okay, because most of the times I actually use this GP. It just comes up with the practice. GPIO.BCM, GPIO.set warnings, and GPIO.setup, and then GPIO.in. Okay, and then pull up and down. Okay, in this I'm actually going to select GPIO dot pull up down. Here I'm actually going to select up. Okay, here PUD means pull up down. Okay, here we are actually going to select up. Okay, that's great. And I'm actually going to create a while loop over here. It will be really a good idea. Here I'm actually going to create one variable just to go up with input right now. Which pin number we are actually going to use? 21st pin number. Okay, and then I'm actually going to print the values over here. Value. And what we can actually do is one more function. It is actually related to Python, str. Okay, I'm actually using a string function which can convert any kind of numbers or float values to a string. Okay, I'm just converting the x. Okay, Python naturally put everything in the new line. Okay, so no problem at all. Okay, if the x value is actually 0. Okay, if I press the button means what needs to happen. Okay, I will comment it out as well. Okay, so don't worry. Okay, so okay, first of all we will analyze this. Okay, afterwards we will go with everything. Okay, so no problem. And just to give the time dot sleep as 0.1 or 0.2. Okay, just give 200 milliseconds, just nothing but 0.2 seconds. Okay, here button interface. It's going to give button interface over here. Okay, let's see. Here you can see, guys, the value 1 is actually coming up here. Okay, I will just start my video. Okay. Can you able to see? Okay. Analyze both the screen and the video. Okay. At Vigneswaran Swaminathan, you can actually able to see the video because I have connected to phone. Okay. So this is the actual push button. It is quite different. Okay. Not on general purpose. It is an industrial grade button. Okay. So I'm just going to press this. Here you can see. Whenever I'm just pressing this button, okay, just pulled to low. Okay. Otherwise, you just stay pulled up because I have used an internal pull-up resistor. Okay, to avoid the pin floating. Okay, just press the button. You can see.
Sir, I could not see the video, sir.
At Vigneswaran Swaminathan, you can actually see the videos. Okay, at Vigneswaran Swaminathan. Okay, so that profile, in that profile only, I'm actually showing the video. Okay, others, can you able to see? At
Yes, yes, sir.
Yes, sir.
Yes, sir.
Okay, okay. Thank you so much. Thank you so much. That's great. Just stop the video and just come up with a little bit of experiment. Okay. We actually know one pin is actually connected with LED. Okay. So GPU.setup. Here I'm actually going to use 14th pin. Okay, this time 14th pin. Okay, and the kind of setup for this particular pin is output. Okay, so go up with GPIO.out. Okay, So I'm just setting this pin as an output and 21st pin as an input, and also configuring the pull up and down as pull up. Okay, so that's it, guys. Very simple. Okay, as a faculty members, you all know C, I think. Okay, if you know C, these are all actually nothing, honestly speaking. Okay, only thing is a little bit of practice you have to do. Okay, you have to do a little bit of practice and you have to care for those things with the basics. Okay, if you can means, then you can achieve something better. Okay, so now what I'm actually going to do is not only the results we are actually going to see. Okay, here I'm actually going to provide if condition. Okay, if x is 0, okay, because it will be pulled to 0, right? Whenever we are pressing the button. At that particular time, what we are actually going to do is GPIO dot output 14,1. Okay. Otherwise, what I'm actually going to do, okay, we can give else, or else no problem. We can go with a consecutive statement. Okay. If it is actually pulled up, no need to turn on the LED. Very simple, guys. Okay. Here I am just going to print LED turned on, and then here actually going to do LED turned off. That's great. Sorry. Okay, now we can actually going to control something based on the if statements. Okay, if the button is pressed, okay, it just to give an some understanding. Okay, with both Python and Raspberry Pi hardware. Okay, for that only we are actually doing some experiments. Okay, nothing more or less than that. Okay, only the way to understand things. Okay, with initially whatever the time frame that we have allocated for this particular session. Okay, so just run over here. Okay, the LED is turned off, right? Okay, once I press the button, okay, I will show in video as well. Okay, don't worry. LED turned on and the value is also 0. Here also LED turned on. Okay, that's great, really. Okay, that's really impressive. Now I will show you the result. Okay, same profile, Vigneswaran Saminathan. There you can actually see the video. Okay, so I will start the video over here. Okay, here you can see. Once I press the button, here you can see the LED is turned on. Once I release the button, the LED turned off. Once I press the button, you can see the LED turned on, right? Once left out, you can see over here, LED turned off. Can you able to see? At Vigneswaran Saminathan.
Yes, sir. Yes, sir.
Thank you so much. That's great. That's great. Okay. Saumya Jyotidan, they have asked one question called what is the function of BCM? Can you please say? Okay. BCM, which is actually nothing but the manufacturer. Okay. Which is nothing but I will actually show you. Okay. Broadcom. Okay. These are all the companies, they are actually producing the chip. Okay. Raspberry Pi is actually a brand. Okay. But the heart is actually provided by this company. Okay. I actually returning writing like here you can actually see. Okay. Here you can see 21, 14. Okay. All those are actually the chip numbers. Okay. Not the pin numbers of the Raspberry Pi. Okay, here you can actually see. Okay. Yeah, from here you can actually clearly see, Soumya. Okay, here you can see. So these are all the pin numbers of the Raspberry Pi. Okay, I accept that. Okay, completely I accept that. Okay, but this pin numbers is not equal to the actual general purpose input output. Okay, here you can see for the 40th pin number, you can see GPIO 21. Okay, and for the GPIO 14, okay, the pin number which is allocated is 8. Okay, if you need to use the actual board number means you can go ahead. Okay, but always recommended to use the BCM numberings. Okay, for that only we are actually setting the mode to choose everything according to the BCM numbers. Okay, BCM numbers means the chip have pinouts. Okay, from the pinouts only they have actually take some of the pins for the connecting LEDs, connecting some of the PWM. Okay, to control some motor speed. Okay, up to DC motor. Okay, it can actually able to control, and also for SPI I2C. Okay, they have just created some of the pins for that. Okay, because some of the times if you are actually using 14th pin means there you will it will actually throw an error. Why? Because it is ground. Okay, so that is the actual reason why you have to go for the actual BCM numbers. Okay, can you able to understand?
Yes, sir. It is clear, sir. Thank you very much.
Okay. That's great. And with that, what we can actually do is we will connect one IR sensor right now. Okay. So here you can actually see this is an IR sensor. Okay. So it is actually having an 4 pinouts. Okay. One is the VCC. Just a second. Okay. An IR sensor. Okay. Here you can see, guys, I'm actually using the VCC pin. Okay. So for powering this module, okay, it's always recommended to use the 3.3 volt pin, okay, rather than 5 volt, okay, because it have some potential to damage a particular pin in the chip, okay. So then whole 4,000 or 5,000 rupees what you have actually spent, it will go in vain. Okay, so you have to remember to provide 3.3 volts. Okay, 5 volt, it is not a problem for a shorter duration of time. For the longer duration, what you have to do is you have to provide to the 3.3 volt. Okay, and ground, you have to provide to ground. Okay, any lot of grounds of the Raspberry Pi is actually there. You can choose any of the grounds, and D0 they have connected with the one GPIO pin. Okay, in this case, I'm actually used GPIO 16. Okay, so I'm just confirm with it. Okay, just wait a second. Okay, that's great. You can actually go ahead and construct a program as well. Okay, from here on. Fine. The GPIO dot output 14,1, and we have done light. Okay, for the button interface. Okay, just as a same, I'm just going to copy all of these things. Okay, very similar program. Okay, it doesn't have ADC. Okay, so we can't able to provide the time for connections because the ADC chip we have to use with the Raspberry Pi. Okay, because it is a processor, right? they doesn't have come up with ADC. Okay, that's a problem. But anyhow, we are just going to share few things with the IR sensor. Okay, so okay, so in this case, the pull up down. Okay, this argument is actually not needed. Okay, why? Because the sensor itself is having an external pull up resistor with it. Okay, so there is no need for an internet pull up resistor. Okay, so I'm just going to delete this. Okay, I'm just going to edit few things only. Okay, we'll be amazed. Okay, 16. Okay, that's great. Just going to provide like they're also 16. Okay, I'm just reading from the 16th pin. It is actual meaning here, and print the value like 5, and then time. That's great. And GPIO dot output 14,1. Okay, means LED turned on. 14,0 means LED turned off. Okay, the same experiment, but with a different perspective. In this case, we have actually used an IR sensor. Okay, maybe like a few people may not from the electronic background. Okay, for them, I'm actually show this particular stuff as well. Okay, by spending a minute or 2 minutes of time. Okay, here you can actually see. Okay, so this is the actual IR sensor, guys. Okay, it just have 3 to 4 pinouts. Okay, in connections we have 4 pins. One is an analog pin, one is digital pin, another one is VCC and ground. Okay, but here only 3 pinouts. One is VCC, ground, and digital output. Okay, only these 3 pins are actually available, and this one is the potentiometer. Okay, potentiometer, what is actual purpose here means it will actually change the intensity of the detection. Okay, how far the IR sensor rays will actually go. Okay, so this is the LED which actually emits the IR rays, and this one is the observer. Okay, if the sensitivity is very large, okay, it can actually travel to a lot, quite more distance. Okay, like this sensor is actually quite third party and just provide around less than a meter. Okay, but if we just put the sensitivity full means we just detect quite accurate as well. Okay, so this is a sensor we have used. Okay, this one is a transmitter, this one is a receiver. Okay, the black surface we all know. Okay, it always absorb the light. Okay, it will absorb a lot amount of light. Okay, but here what it will do is once we just see an obstacle, okay, we just go and hit here and absorbed by this black LED. Okay, it is how the things will actually work. Okay, so that's great. Okay, the same program, everything is actually same. Okay, here what we can actually say, IR sensor interface. That's great. Any errors? Nothing. Okay, so I'm just placing the fingers. Okay, here you can actually see the LED is also turned on. Okay. Just take away my hand. Okay, so just turn off. Okay, I will show in the video, guys. Okay, so very interesting results. Just a second. Turn on the video. So this is the IR sensor. Okay, here you can see this is IR sensor. Actually, this is the black surface, guys. Okay, so the chair I'm actually using, right? It is actually the black surface. Okay, so it will absorb all the infrared rays. Okay, what else is actually coming from the white LED? Okay, from the white LED, it is actually the transmitter. Black is actually the receiver. Okay, it is actually the black chair, right? So it just absorbs everything. Okay, Now what I'm actually going to do is I try to actually going to provide some obstacle over here. Just take the okay. It is a green surface, so it just easily reflected, and you can see LED just turned on. If I actually take from here, there is no obstacle upwards, so LED also turned off. I actually bring it over here, close to the one, so you can actually see LED is turned on. Okay, can you able to see the video, guys? Anyone?
Yes, sir.
Okay. Fine. Thank you so much. Okay, if I actually take, okay, just turn off. Okay, so that's great. Okay, based on that only we have to create. Okay, for each and every application. Okay, first of all, we have to do a lot of stuff. Okay, the requirement analysis. Okay, from the very requirement analysis to everything, we have to work on it a lot. Then only you can able to get a very good product. Okay, otherwise it is not at all possible. Okay, in a day or two. Okay, a proper planning is actually be there, so then only you can able to produce the same. Okay, what is required for the application. Okay, based on that you can construct. Okay, we have seen 3 interfaces today. Okay, we have a short time. Okay, we have 3 interfaces. One is LED, how to interface. Next one is button with pull up and pull down concept, and then IR sensor interface. Okay, and one more thing we will actually do is nothing but configuring a ThinkSpeak cloud. Okay, it is actually a wonderful platform where we can actually send a very good amount of data. Okay, just a second. So here you can actually see, guys, Raspberry Pi has a web client. Okay, so here the Raspberry Pi is having a push button. Okay, in this case, we will change one thing. Instead of push button, what we can use is we can use IR sensor. Okay, we can use IR sensor. Okay, with IR sensor, we are just going to give a get request. Okay, and to the ThinkSpeak, and with that we will get a wonderful response from the ThinkSpeak network. Okay, so that is what just we are actually going to ping one server. Okay, it's just a demonstration. Just look over here. Okay, if we have a chance to in a detailed session, means it could be much better. Okay, to share a lot of knowledge with you guys and lot of experiments. We are just go up with basics. Okay, so with the time allocation. So right now we can actually give and get request to a particular server, and will retrieve the response as well. Okay, and just come over here. Okay, I will actually show you how to create an account as well. Okay, very simple. Okay, ThinkSpeak, just go to ThinkSpeak over here. Okay, from here on, just come into here. Okay, just see the cursor position carefully. That's very important. And big 797. Okay, of whatever it's. Okay, no, that's fine. Okay, I have tested last day. Okay, so and cleared as well. Okay, so just to create everything. Okay, in my case I have just signed in. Okay, so you can actually create your own account. Okay, it is very simple. Okay, so no need to worry. So the first interface will be my channels. Okay, In this case, I'm just going to delete a channel. Okay, just go to channel settings and I'm just going to provide delete over here. Here, in this case, I'm just going to click new channel. Okay, the name is we can provide testing. Okay, data from Raspberry Pi is a description. Field label maybe like value, something like that. Okay, we can put like that, and just come below, give save channel. Okay, within few seconds we have created a channel, and just come over here to the API keys. Here you can see this is the request we are actually going to send. Okay, get request. Okay, just to copy over here. Okay, no need to paste it anywhere. Okay, so just create a new program and just comment it over here, paste it. It's no problem. What I'm actually going to do is I'm just going to copy this program. Okay. Just to paste it over here. Sorry. Here I am just going to do one step further. Okay. Import request. Okay. And then very simple. Okay. I'm just going to create a variable response. Okay. In Python, guys, okay, one thing you have to keep it in mind. Okay. You never mind about the variables that you are actually creating. Okay. Why? Because if you just provide x equal to 1 means x becomes an integer type variable. If it is x equal to 0.3 means it just become a float. If x is equal to like a string, if you provide like my name is Vignesh, right? So just provide Vignesh means it will just provide a name as string for the x. Okay. So in this case, what I'm actually going to do is response. Here one method I'm just going to call, very simple, get. Here double quotes I'm just going to provide. What I'm actually going to do is, just a second. I'm just going to copy all those things over here. Here I'm just going to provide field 1 as 1. And when it comes to ThinkSpeak, okay, it won't actually update like this one. Okay, at the time sleep, we just have provided 200 milliseconds. It is not at all good for a GET request. What we have to do is, for a ThinkSpeak, for the open source account, we need to provide at least 15 seconds of delay. Okay, so until then we have to wait for that. Okay, placement is quite wrong here. Okay, just copy this. Whenever the obstacle is there for an IR sensor, what we are actually going to do, we are actually going to provide like this. Okay, inside the if statement, I'm just going to provide time dots. And also the things, okay, just copy this. Okay, we are actually going to send either it is 1 or 0. Okay, so with the value we have, okay, that's the most important thing. 0. Okay, and GPIO. And again providing the time dot sleep as 15 seconds. Okay, so RPI dot GPU. Okay, very simple, guys. Okay, we have just imported and read first, and then we have do nothing over here, even in the while loop. In if statement, what we have actually done is we just have given a response. Okay, in this case we can print response. Okay, response. Okay, it will just give an code, a HTTP response code. Okay, it will provide. That's great. Data to cloud. Okay. Okay, let's see how it actually goes. It's actually turned off, right? Okay, let's see whether the 0 value is actually pinged or not. Okay, here you can see the response have actually came. Okay, let's see, guys. Just go to the view section in private view. Here you can see 0 and 0. Okay, now what I'm actually going to do is just analyze in the charts itself. I'm not actually doing any wonders. Okay, just provide an obstacle. Let's analyze the value. Here you can see, guys, 1, the value is actually came. Okay, and also for the proof, you can see over here, LED turned on. Okay, to see the response, the actual response from the server. Okay, what we have to do is just a print response dot text. I think txt, I think. Okay, if it is show an error, we can actually try in that way. Okay. Sorry. Okay, here you can actually see, guys, from here on it is actually updating. It is an 8th entry. Okay, it is what actually denoting. Okay, we just give the count as a response for the each and every request we are actually making there. Okay, here you can see 9. Next is actually 10. Okay, here you can see 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then a 10 will be actually coming there. Okay, there will be actually some delay. Okay, to show the output over here because the cloud is actually open source, right? Okay, it is quite a crowded platform. Okay, and also it is having a lot of features. Okay, just to walk through over here. Okay, it is actually the private view, right? Okay, so for public view, what you have to do is you have to go to sharing. Okay, in this here you can see keep channel view private, share channel view with everyone. I'm just going to select this one. Okay, now just go to the public view. I can able to see in public view as well. Okay, so that is what the point that you have to keep it in mind. Okay, so just taking a lot of time. Okay, and also just to see in the real time. Okay, I'm just providing an obstacle right now. I'm just expecting the value should be 1. Okay, So maybe from the next response cycle, okay, we will be actually getting the value one. So yes, it just given value 1, and also here you can see the response from this server is just and counts the LED turned on. That's great, guys. Okay, so these are all the experiments that we have actually seen so far. Okay, if fortunately, if there is an extended session which is allocated in near future, or maybe um, based on the planning which is done by the training, okay, we will do a lot of more and more interesting stuff, okay, in near future. Okay, just to give an idea about the Raspberry Pi, okay, because it won't be really good if it is only theoretical, because there is a lot of possibilities to say in 2 hours we can actually go with the theory, we can do hands-on, but I'm not really look like that, and we know what technologies we won't do. We will provide some hands-on, at least a virtual hands-on experience, because these are all the incredible times. Okay, so around 2 to 3 years, we don't know. We just turned our life upside down. We have lost a lot of loved ones during the COVID season. So we can do. Okay, let's hope for the best. Okay, as of now, it is not actually an end. It will be still be continued if we have an extended session. Okay, and that's all for the today, guys. Okay, and hopefully you all have enjoyed this session. Okay, and I'm just open for all the queries. Okay, if you have any doubts in this session, as well as like I said in the start of this session, right? If you have any doubts related to the application area that you are actually working, I'm really happy to help on that as well. Okay, anyone, any doubts? Okay, at least just ask in the chat session as well. Okay, how was the workshop? Just give a feedback. Okay, so your feedback is very much important, and thank you so much. Okay. Okay. Thank you. Okay. So one thing is, I always actually try to be more and more informative because it's very much important as a faculty members, not only faculties, as a mentorship. Okay, I'm also doing for 3 to 4 years. Okay. Yes, I will actually share. Okay, so don't worry. Okay. Uh, just to have this. Okay. Only one thing. Okay, I always like to insist my students. Okay, in each and every time, because I have made a mistake in my career. Okay, because in my initial stages I didn't love C. Okay, C means C language. Okay, nothing else. Okay, C language, C++. The programming means it's quite allergic for me. Okay, but afterwards. Just to forecast how the world is actually moving. Okay, a lot of digitalization we are actually seeing over here. A lot of opportunities in Internet of Things is actually be there. Okay, with that I have usually just to come across the shortcut. Okay, I just straight away go with the Arduino. Okay, I'm not actually complaining about the Arduino hardwares, or else it's kind of things. Even if you actually take a Raspberry Pi, it won't actually give a much more core knowledge about the processor. Okay, it will give you general information. Okay, about how things work, how we can actually do with Python and everything. Okay, but the way to study and any embedded systems, or if you are actually choosing the career to the path of Internet of Things, okay, or maybe an Internet of Things lecturer, okay, more of you will actually become a lecturer. Okay, in the field of Internet of Things, machine learning, artificial intelligence, if you worked on. Okay, so I actually bet, okay, it is a very really good way to study if you are going for the path of the Internet of Things. Okay, very simple. Only 4 steps I have written over here. Okay, C, C++, Python. Okay, whatever the language may come here. Okay, like Ruby, AngularJS, InterJS, AngularJS, whatever it is. Okay, very simple opinion. If you know C, C++, okay, with Python there is nothing. To be honestly speak, okay, C is the only language. It is a base structure. If you know C very well, means C++ you can capture. In C++, one main advantage is you just provide a very high performance in quite doing the hard. Okay, so when we are actually writing the libraries, we actually use C++. Okay, instead than preferring C. Okay, we use both the C and C++ compilers while we are building the program, because C++ gives a very good efficient performance than C. Okay, Python is actually like in embedded also there is actually one Python is actually there. Okay, the name I won't actually remember, but for embedded Python is also there. Okay, so but Python is totally a shortcut. Okay, if you know C, C++ means you can actually write I know Python. Okay, it is actually a combination of both, and the course are actually written in C++ only for Python. Okay, lot of course, lot of libraries. If you actually take internal modules, some of the C++ concepts will actually come. Okay, oops concepts. Okay, it just inherited few things from the C++, Python. Okay, likewise only a lot of things. Okay, initially JavaScript is actually there. Right now, 2 kinds of JavaScript is there. One is Angular, which has been provided by Google, and another one is the React.js by the Facebook. But both core concept is same. Okay, where you have to put the effort means in JavaScript. If you actually go directly to the Angular.js means you will be confused and you can't able to reach the goal. But for the embedded system enthusiast, also for the mentors, also here you can actually see a lot of faculty members are there. Okay, if you are just going to the path in the teaching career for the Internet of Things machine learning means, okay, in an embedded stream, I am telling. Okay, for the cloud it is totally different. Okay, AWS, Azure, some programming languages, okay, which is related to cloud also you have to know. Okay, but here, okay, for the hardware side I'm actually telling, because I'm actually quite good in hardware. Okay, here C, C++, Python, and to learn the machine code, 8051 is the master. Okay, don't jump to the ARM controller. Okay, directly, just go and learn the 8051, or else if it is a microprocessor, go and learn 8085, 8086. Okay, and the next one is PIC or AVR. Okay, between this you can choose anyone. Okay, more than PIC, AVR is actually booming right now because of Arduino technologies. Okay, still both are really good, but the robustness means PIC one, peripheral interface control. Okay, because the architectural design, the kind of rigidness, okay, the PIC will actually provide, not the AVR chip. But AVR is also not lesser than PIC. Okay, so it is a point you have to keep in mind, and then you can go for ARM controller or processors like Raspberry Pi. Okay, so this is how I actually request you to guide students. Okay, so as the chance they have actually given, and you faculty members have a lot of potential to change a student's life. Okay, at least in a class around 70 to 80 people. Okay, maybe around 40 to 50 people in average means. Okay, at least 4 to 5 members will be really enthusiastic about the things what they are actually doing. Okay, at least for them you can just guide them in the way. Okay, so because a lot of the people are actually doing the stuff with Arduino boards. Okay, So it's really good to see to perform whatever the things which we are doing in a complex way. But one thing is they are just forgetting the basics. Okay, they never turn back and look the basics. So that was the actual problem with Arduino. Otherwise, it is a wonderful platform only. Okay, the only thing is we just provide an upper stack layer. Okay, we just make the things quite fuzzy. Okay, so it is a thing, guys. Okay, so really happy to be here, and it is actually more than 50 to 60 sessions, I think. Okay, from here on, I have some count. Okay, and with it 10 to 15 higher official meetings we have attended, and also given some of the training sessions. Okay, even if you have any kind of doubts, okay, even I can give my contact number as well. Okay, between 6 to 8 p.m. I'm actually open to provide answers. Okay, whatever the doubts you have, okay, you can just post it to me. Okay, if I actually get means, I will surely take a message. Okay, so before that, I'm having in work. Okay, so that was, and also for contacting Ravi sir, okay, of Innovaskill Technologies. Okay, and you can contact him for further advice. Okay, for future sessions as well. Hopefully, I'm actually waiting to provide. Okay, and I actually initially said, okay, so AICTE is actually doing a wonderful job. Okay, how many of the mentors or faculty members are totally involved here? Okay, I will just write my email ID. Please wait. That you can actually send mail from here. Okay, 701. .com. Okay, it is actually one of my mail ID. Okay, here I will answer your queries. Okay, if you have need to contact directly means that also no problem for me. Okay, just ping me. Okay, if I actually see means I will provide suitable answer. Okay, based upon your okay, and also any application area doubts. Application area doubts. Okay, because I guess a few of my faculty members right now, okay, who have actually taken class for me, they are working in a project, okay, using a Raspberry Pi. Okay, so that's why I actually asked, okay, during the start of the session. Okay, and it's really a great job from AICTE to conduct these kind of sessions, and it is actually very much needed for everyone, okay, to share the knowledge. Knowledge is the God. Okay, thank you so much. Thank you so much. Sir.
Yes, sir. Yes, sir. Thank you, sir.
How was the session?
We can wind up the session now. Actually, Vigneswaran sir taken more than the scheduled time actually. Because of his interest, he took more time and actually given a lot of informative sessions and provide hands-on training also how to use the Raspberry Pi. And given a lot of information, hands-on training, not right, instead of theoretically given practical sessions. So very nice session, sir. Thank you very much.
Thank you, sir. Thank you so much, sir. Yeah, in your future, I can expect from your call.
Yes, sir. Definitely.
Yeah, sure. Okay, sir. Okay, thank you all, guys. Thank you, everyone. Okay, thank for your love and support. Thank you.
Thank you, participants. See you tomorrow morning.